Okay, so let's talk about the volume of three kinds of three-dimensional shapes: cylinders, cones, and spheres. And I've got an example of each one here. And really we're talking about the formula for each one of these volumes. So you'll want to learn those formulas, and then we'll use each one really briefly. Okay, so for cylinders first, the volume is just basically the base, the area of the base, times the height. And the area of the base is going to be pi r squared because that base is a circle with radius of r. So this is probably the formula you want to be paying attention to the most, because usually you'll be given r and h, and you can just plug those in order to calculate the volume of the cylinder. Now the volume of a cone is very different, but it's also similar, because you'll see here the formula is 1/3 of the base times the height, or 1/3 of pi r squared h, because its base is also a circle with radius of r. Now what's really interesting here is that it seems very similar to pi r squared h, but it's just 1/3 of that value. You could prove this. One of the ways to prove it is to have a cone with a base that has this radius here, and then have a cylinder with the same radius. If you fill this cone up with water, turn it upside down and fill it with water, you'll fill it up exactly 3 times, pouring it into the cylinder each time, and at the 3rd time, you'll fill up the cylinder exactly. That's just how it works. And then a sphere, it seems a little bit similar too, but it doesn't have a height, right? It only has one dimension that we need to pay attention to, and that's that radius. And the volume of the sphere is 4/3 pi r cubed. Now let's go ahead and use each one of these formulas really briefly. First we'll try the cylinder. Find the volume of a cylinder with radius 3 and height 4. And here it tells us express in your answer in terms of pi. Okay? So we're going to go ahead and use this equation up here, this formula, volume equals pi r squared h. We just put in the values given to us. So volume equals pi r squared h. Volume equals pi times 3 squared times 4. So I've just put in 3 for the radius and 4 for the height. Now we can go ahead and square that 3 so that volume equals pi times 9 times 4. And then 9 times 4 is, right, 36. And then you probably want to keep the pi on the other side, so we just rearrange it to look like that. Volume equals 36 pi. And here it told us we can express our answer in terms of pi, so that is the answer. A lot of times we leave pi in the answer. Now, let's do a problem with the cone. So find the volume of a cone with radius 3 and height 4. So here the dimensions are the same as what we had over in this problem, but now it's just a cone. And here it tells us use 3.14 for pi and round your answer to the nearest tenth. So remember, 3.14 is approximately equal to pi, and a lot of times when you want a decimal answer, you'll use 3.14 instead of leaving pi in the answer. So now let's go ahead and set up our equation. Volume equals 1/3 pi r squared h. That's our formula for cone here. We're going to go ahead and put in our values for r and h, just like that. Now we'll keep going here. So it's volume equals 1/3 of 3.14, which we put in for pi also. 3.14 we put in for pi. And we know 3 squared times 4 is the same as the math we did over here. So we know that that equals 36. Now from here, you can multiply it all out with a calculator. I like to recognize that 36 is divisible by 3. So 36 divided by 3 is 12. So then we can write that that's the same as 12 times 3.14. And then I like to use a calculator from there. So if you do that with the calculator or by hand, you'll get volume equals 37.68. And then our problem asked us to round to the nearest tenth. So we'll go ahead and do that. And volume equals 37.7. So that's how to calculate the volume of a cone. Let's do one now for a sphere. Find the volume of a sphere with radius 3. And remember, they don't give us any other dimensions of a sphere because it doesn't have a height. All you need to know about a sphere is what its radius is. And here they're saying express in terms of pi. Okay, so we'll go ahead and use our formula, 4/3 pi r cubed. One of the things that's interesting is that all of these are going to be volumes, so they're going to be in cubic dimensions. Here with a cylinder, we have an r squared and an h. So the r squared plus and the h dimensions are going to end up being cubic. Same with r squared h here. Here we don't have a height, so that r is being cubed, and that's how we get to a cubic dimension for our units. Anyway, let's go ahead and put our radius of 3 into the equation, into the formula here. And so we have 4/3 pi times 3 cubed. Okay, you can solve this in a number of different ways. One way is to go ahead and do the cube of the 3 there. So you have 4/3 times pi times 27. I like to recognize then that 27 is divisible by 3. So 3 goes into 27 9 times, so we can write it like that. You could just plug everything into your calculator instead and do it that way. Or you could even recognize over here that this is 3 cubed and there's the 3 down here. So one of those 3's will cancel and you'll just have 3 squared, and that'll be 9. Lots of different ways to solve this. Now we know that 9 times 4 is 36, and so we'll go ahead and write that volume equals 36 pi. Coincidentally, that's the same answer that we had over here. Isn't that interesting? The height of this cylinder happened to be just the right height in order to equal the volume of this sphere over here that had a radius that was the same as the base of this. But that's just a coincidence. And so that's our answer, V equals 36 pi for that sphere too. So now you can find the volume of these 3 different shapes that have to do with circles.